Today's submarines are the pinnacle of modern technology.
A sub's more complicated than a plane or a rocket.
An 8,000-ton vessel lurking up to 1,000 feet deep, carrying the most destructive missiles ever, equipped with nuclear warheads. In 1971, Le Redoutable, the Redoutable, is the first French submarine able to deliver the ultimate strike. Yet, to fulfill its role, it must stay hidden from the enemy deep in the oceans for weeks or even months. To achieve this, an unlimited source of power is needed, a nuclear reactor. The result is a ship that doesn't need to surface anymore, a submarine in the truest sense of the word. 50 years after the Redoutable was commissioned, the latest version of these exceptional vessels comes out of the naval factories at Cherbourg. The Suffren, the sum of the most advanced technologies.
The design of the Suffren class began in the late 90s for a ship that put to sea in 2020.
With its latest generation sonar and its ultra-silent propulsion, the Suffren is a perfect predator of the seas. A legacy of inshore infiltration techniques in which the French Navy excelled during World War II, when the Ruby wreaked havoc on the enemy.
The Ruby sank more ships than the entire French Navy during the war.
The Ruby has become a legend in the world of submarines. So has the Redoutable with its nuclear armament, and the Suffren, named after a French admiral who rose to fame during the American War of Independence. France is one of 6 countries operating nuclear submarines. Their missions are shrouded in secrecy. Their construction is one of the world's best kept secrets.
In France, we build a generation of submarines about every 25 to 30 years.
The design phase alone takes about 10 years. On average, 12.5 miles of pipes must be arranged in the hull of a submarine some 400 feet long. Yet, nothing here is superfluous. Challenges abound, and they're huge. Not least, providing space for a 135-strong crew, performing their duty 1,000 feet under the sea. Once submerged, a submarine is near untraceable. It can get close to hostile shores without disclosing its position. Yet, for a submarine to become a true underwater vessel, there needs to be a revolution in its operating mode. And that's achieved in the 1960s with the Redoutable. For the first time, a nuclear reactor is implanted in a French submarine. It provides the vessel with a gigantic amount of energy. It constantly recharges the batteries and provides oxygen indefinitely. The Redoutable does not need to surface for months. Its dimensions of 419 feet and 8,000 tons allow it to displace a hitherto unthinkable arsenal of weapons, and opens up options that had previously seemed impossible.
It was a game changer.
In the 1960s, the Americans, as well as the Russians, are operating nuclear-powered submarines. Now France also intends to build one. Yet the French aim for more than just revolutionary propulsion. The new submarine is to carry nuclear missiles from the start. No navy has ever launched these 2 projects at the same time. It took the Americans years to master nuclear propulsion before they added atomic weapons. The French will go about it simultaneously.
France was the first country in the world to start building a nuclear-powered submarine able to launch ballistic missiles. So this somewhat surprised the world.
In 1964, the naval group factories in Cherbourg are expanded into a huge construction site.
We're talking about almost 125 acres. The workshop for the hull alone measures 10 acres or 4,000 square meters. It's colossal in its height, its width, its overall dimension.
The first step is the construction of the essential part. That will contain all the technologies and allow total immersion, the hull of the boat.
When a submarine dives, the hull compresses, so it must be able to withstand the deformations underwater, which are caused by the relative pressure at the depth where it operates.
Forces that require a special metal for the hull.
The Redoutable is made of a high-yield strength steel that can be welded. This metal must be able to bend to a certain extent, since a submarine deforms like a plane in flight, so it must be flexible.
The hull of the Redoutable is built by sections. Each one is composed of 4 or 5 parts.
They are large plates, flat and completely rectangular, between 5.5 and 7.5 yards long.
To give them a rounded shape, the Cherbourg site can call on some extraordinary machines, like this 12,000-ton hydraulic press. A monster capable of bending the huge metal plates required for the submarine.
We had to develop all this from scratch. There was no formula. So you try until you find the right recipe, and then you don't touch it anymore.
The expertise of the welders is essential when assembling the parts. The Redoutable is intended to operate at a depth of more than 1,000 feet, resisting the immense pressure of the deep.
The hull is designed for a specified depth. There are safety coefficients, fortunately, but at some point, if the boat goes too deep, the hull will be crushed.
So the welding must be precise right down to the last millimeter to avoid any fragile points in the hull. Then, the 24 sections are joined into a single entity. The giant of the seas takes shape. Its final size is 419 feet, exceeding the height of the second floor of the Eiffel Tower. The hull is the main rampart against the water and the pressure it exerts. And there's another force to be contained. Hidden inside its steel plates is one of the greatest technological advances of the 20th century: the nuclear reactor. It's a revolution in the field of submarines. The reactor enables a sub to stay underwater for months, whereas previous conventional submarines were mere submersibles.
They had a capacity to stay deep for a certain time, but after a while they had to surface and recharge their batteries.
It was the weak point of submarines before the advent of nuclear propulsion. The electric batteries that allowed them to run underwater were fed by diesel engines, which could only recharge the batteries when the submarine was at the surface. They couldn't operate underwater, as they needed oxygen and had to vent their exhaust, a massive constraint at the time.
They could stay underwater for a span of 48 to 72 hours at the longest.
A limitation that makes submarines easy prey for planes and surface ships. With a boat like this, carrying nuclear missiles cannot even be envisaged. To provide a realistic deterrent, the vessel must hide underwater and never come to the surface. Back then, the equation is impossible. Until the advent of the nuclear reactor powered by uranium.
Instead of having 100 tons of diesel, you have something like this. See, that's enough. People had never seen the like of it. You replace 100 tons of fuel with 1 gram of uranium and do what you want.
Uranium is a heavy metal that is found all over the planet. Together with other materials, it keeps the mantle of the Earth at a certain temperature. The energy of uranium is immense. Yet to exploit it, you must succeed in concentrating it, and that's a highly complex operation.
You can't just use the natural uranium that comes out of a mine. You need a special plant to do what is called enriching. The uranium you find in the mine is a bit like apple juice, which contains a little bit of alcohol and a lot of water. In natural uranium, there's a little bit of radioactive uranium, but the vast majority, 99% of it, is not. That's of no use to you at all.
Concentrating the uranium for the Redoutable is done at the Cadarache plants in southeastern France. Yet how do you build a reactor in a space as small as a submarine? Even if it is the Redoutable, the largest ever built in France so far.
The first reactor that was designed, well, it did not fit into the hull. So, between 1958 and 1963, the engineers aimed to build a reactor whose dimensions would allow it to be installed on a submarine, the first prerequisite. And secondly, it needed to have radio protection devices that allowed the crews to live alongside it.
Once a solution had been found that reduced the volume of the reactor, the other great challenge had to be met. The quantity of enriched uranium on board is several hundred kilograms. The exact mass is kept secret, but it is considerable and implies a deadly level of radioactivity for the crew. To minimize exposure, the reactor is placed in the back of the Redoutable.
The section is a little under 11 yards long and wide. So, with the Redoutable's diameter of 11 yards, the reactor just fits in.
The section is hermetically sealed. Protection of the crew is a top priority.
There are sensors that constantly check the level of radioactivity. In case of any anomalies, there are provisions to isolate the compartments, to prohibit access, yet allowing the crew to investigate what is going on.
The reactor, the nuclear boiler room, weighs more than 500 tons. The mass of the annexed piping with their circuits amounts to another 1,000 tons. The boiler room is the most complex part of the Redoutable. Temperatures, pressure, radioactivity all pose a different challenge, starting with the huge tank holding the essential ore.
L'uranium, c'est donc le cœur du réacteur.
Uranium is the core of the reactor, and it's in this core that the nuclear chain reaction occurs, where the uranium atoms are split, releasing energy.
Qui libère de l'énergie lorsqu'il se fissure. Cette énergie-là, on va.
This energy is then recovered and transported simply thanks to water that passes through the uranium core and heats up while doing so.
Qui s'échauffe lors de ce passage-là.
The temperature of the water is well over 100 degrees Celsius. However, the pressure in the tank keeps it from boiling, and eventually, steam is produced, which is led through a pipe and drives a wheel.
The turbine shaft turns faster and faster and thereby transforms the energy supplied by the steam into mechanical energy by making a rotation axis turn.
The wheel is connected to an alternator. The result is an instantaneous production of electricity.
And this current is going to charge the batteries. It's exactly the same as a turbo alternator at any power plant.
The uranium is so powerful that the operation can be repeated several thousand times. Thanks to this infinite source of electricity, the Redoutable can stay submerged for months. The batteries feed all machines of the vessel. Yet, even if the submarine can remain indefinitely at depth, there's a problem. How can the men breathe in a closed space for months on end?
Total independence is only possible if you can solve the problem of the atmosphere. For that, you need what's called a decarbonation plant, an installation that cleanses the atmosphere of polluted air molecules.
The air is led over a material that blocks the larger molecules. The abundance of electricity provides the submariners with the cleanest air possible.
A nuclear core can last between 10 and 20 years. It's a source of energy that is almost unlimited as far as the needs of a submarine are concerned. So the engine could run for 10 years if the personnel were able to live 10 years underwater. It's a revolution that has completely changed the way submarines are used.
Apart from not having to surface to charge the batteries, the submariners also have a tremendous asset to move at depth. The reactor is so powerful that it's also used to propel the boat. And it's one of the key parts of the Redoutable that benefits from it, the propeller. This gigantic structure is composed of 7 blades, which drive the Redoutable forward. The steam of the reactor turns a second turbine, which feeds the propeller. The propeller is one of the most complex parts of the Redoutable. The submarine's mission requires getting close to the enemy without giving the vessel away. And what generates the most noise under the sea is the propeller. The problem with any propeller is cavitation, little bubbles formed by water vapor.
When they explode, so to speak, they produce a noise that is extremely easy to detect and that signals a submarine.
This treacherous noise can endanger the boat and its mission. It's therefore necessary to build a propeller limiting this cavitation. The designers spent thousands of hours to find the best profile. Without today's computers, it's a colossal effort.
On the Cherbourg site, there were armies of draftsmen at work. And you can imagine that when they noticed an error that had to be corrected, their task wasn't made easier by that.
Once the design is established, models are immersed in tanks to understand the impact of the blades at depth. Yet to manufacture them, you need an alloy that allows high-precision curves to be created on the blades. The answer is the Q-Pro aluminum, an alloy of copper and aluminum that can be melted and then forged into shape. Combined with the energy of the reactor and its uranium, the propeller is a technological marvel, providing autonomy, power, reactivity. Thus, France joins the Americans, the Russians, and the British, who already have this technology. Today, China and India have become members of the exclusive club of nuclear-propelled submarines. All other countries have given up on the idea, as the perimeter of radioactivity proved too much of a constraint.
Several countries tried it on civil service ships, the Japanese, the Germans, and despite having levels of technology comparable to France at the time, they didn't get there because the doses that were received by personnel in the vicinity of the reactor were too high.
Yet implanting a reactor is only the first step. The Redoutable may now be able to hide for months anywhere in the oceans, yet it must still be equipped with nuclear weapons. Missiles similar to rockets coming out of the depths to reach the atmosphere, enter space, and come down again on the target at nearly 17,000 miles per hour.
We didn't have any of the technologies that were needed to make a missile or nuclear warheads.
That meant starting with a blank sheet of paper and inventing everything. Above all, the missiles, since buying them from the Americans is a no-go. France's head of state, General de Gaulle, is hell-bent on total sovereignty in terms of nuclear deterrence.
France aimed for complete national independence, unlike the British, who bought their Polaris missiles from the Americans. France was to develop everything themselves.
Ballistic missiles are in fact rockets. They weigh about 20 tons each and are nearly 11 yards long. Yet, how to launch them underwater? How to make them watertight? A first proposal to encase them in a kind of diving suit is rejected.
If you launch your rockets at close intervals, it means that you launch them at a close distance from each other. So there'll be things floating low in the water when the next rocket is fired, which may cause problems.
Lorsque la fusée suivante arrive, ça peut poser aussi des problèmes.
It's not a good idea to have lots of stuff floating on the surface or sinking while you're underneath.
Protecting the missiles via a waterproof shell is abandoned. Yet, it's also out of the question to come up to the surface to launch them. The engineers will ponder over this problem for several years, until they finally come up with a solution.
La fusée, lorsqu'elle est mise à feu,
when the missile is fired, it goes out in a gas bubble. That prevents direct contact with the water.
Et qui lui permet de ne pas être directement au contact de l'eau.
The first ballistic missiles mounted on the Redoutable have a limited range of slightly less than 1,600 miles. In terms of deterrence, it's definitely a weak point. In the Cold War of the 1960s, it meant having to go dangerously close to the Soviet landmass.
To be able to hit Moscow with weapons that have a range of just 1,600 miles, the patrol zones of the Redoutable, with its first generation of missiles, were limited to the Norwegian Sea. This was extremely disadvantageous. To avoid predictability of a sub's whereabouts, the patrol area must be very large.
Hence, the Redoutable needs long-range missiles. Yet, when trying to achieve a range of more than 2,500 miles, which would allow for a larger infiltration perimeter, the engineers are confronted with a major difficulty.
You need a higher fuel load in a missile, yet its dimensions are constrained by the missile tube.
Today, the latest French submarine launched in 2010, the Cherbourg, is equipped with M51 missiles. They have a range of more than 4,350 miles, 3 times more than those of the Redoutable. Yet during the 1960s, it was enough to constitute a credible deterrent, not least because France demonstrated its capabilities through numerous nuclear tests.
In the poker game of deterrence, you must be able not only to bluff your adversary into believing what you have, but also to convince him that you're not bluffing. Demonstration is an essential element of deterrence.
Lurking undetected in the deep, able to strike the enemy without giving away the position of the launch pad, this is the incredible potential of the nuclear-powered submarine. Secrecy is fundamental in this kind of mission.
No one knows where the submarine is, neither the President of the Republic nor the staff of the Strategic Ocean Force. The commander is totally free to choose his own course.
Being thousands of miles from the sub's base, communication becomes a challenge.
It receives instructions, but doesn't emit any signals.
To avoid being located, the Redoutable remains silent during a mission. However, it's not deaf. It must be able to receive the firing order if the situation requires it. But there's a problem, and it concerns the radio waves. They circulate perfectly in the air, yet they don't penetrate the sea, and even less so at depths where submarines operate. So the Navy relies on other frequencies.
We use a particular wave called VLF, very low frequency.
These waves are transmitted by huge antennas of 1,000 to 1,300 feet in diameter. There are 4 such sites in France. The Redoutable served for 20 years under 19 commanders, until it was paid off in 1991. It's now exhibited at the Cité de la Mer in Cherbourg as an exceptional heritage of what engineers in the 1960s managed to achieve, starting with a blank sheet of paper. Today, the Terrible and 5 other vessels of its class have taken over, lying in wait, ready to launch nearly 100 long-range nuclear missiles. Yet, even if they're more sophisticated than the Redoutable, they are still vulnerable at the very start of their missions.
When they leave the port, there may be hostile submarines in the area, trying to track them and establish where they will be going.
So, to ensure that no potential enemy will be following the Terrible with its 16 nuclear missiles, France launches a gigantic construction site to build a new generation of so-called SNAs, nuclear attack submarines. They are smaller, more discreet, and fitted with an arsenal that's state-of-the-art. And the first of the line is the Suffren. It's packed with the latest generation of torpedoes and anti-ship missiles.
What's new is the deployment of the naval variant of the cruise missile.
It can travel up to 625 miles to reach its target, meaning it can be fired discreetly. The engineers have worked on the noise of the submarine and especially on the nuclear reactor. Everything is suspended to avoid contact with the hull of the submarine. The result is exceptional, as is the new propeller. To avoid too much cavitation, those little bubbles that can be heard from several miles away, the builders have encased it in a nozzle. The Suffren is the first French warship equipped with the new F-21 torpedo. It's equally effective against submarines and frigates. Its destructive power is frightening. The more so, as its run can be controlled up to a few seconds before impact.
It's connected to the submarine by a wire that allows guidance by the operator.
Each torpedo has 30 miles of optical fiber connected to it, the maximum range of the weapon. Thanks to its propulsion, it runs at over 60 miles per hour, and carries 200 kilograms of explosives. It's a devastating weapon that can creep up on any hostile sub from beneath. It may run at a depth of over 2,000 feet, maybe more. Its exact data is kept secret. But the Navy also requires a weapon that can be used on the surface. And there is indeed a new missile that's promising. Alas, it has never been fired from a submarine.
Back then, only Frem-class frigates carried this new missile that flew close to the speed of sound.
The 1.5-ton cruise missile is a weapon with exceptional potential. Yet a problem appears while the Suffren is still under construction. How to launch it when underwater? Its design doesn't allow it to be surrounded by a gas bubble like the nuclear missiles. The solution is a cruise missile with a mantle.
It was put in an underwater container.
A 23-foot-long casing covers the entire missile and prevents water from seeping in. It's designed to detach from the missile as soon as it reaches the surface. The missile is then propelled conventionally until impact. The Americans have chosen another way to integrate it into their submarines.
They put vertical tubes in the submarine for the launch of their strategic missiles. That means, however, that you do not only have the torpedo tubes in front, but also a rear section that makes the boat much longer.
A concept that imposes a much greater overall weight. But for an SNA, a nuclear attack submarine, its mass is the determining factor in the speed of its maneuvers. The French Navy demands that the engineers find another solution for these new missiles. They decide to dispense with the intended design of the front part of the submarine. The cruise missiles will pass through the same hatches as the torpedoes. Torpedoes and missiles that number in the dozens pose another difficulty inherent to submarines. When a missile weighing more than a ton is fired, the sub becomes unbalanced. The handling of a submarine consists above all of the art of keeping it on an even keel when submerged. That's why some sectors of the submarine are reserved for this precision work: the ballast tanks.
To float and sink, the boat has to adjust its buoyancy. This must be done permanently, and it's achieved by proper use of the ballast tanks.
Donc il y a un équilibre permanent qui est ajusté dans le sous-marin, et cet équilibre, il est ajusté par ces ballasts.
The ballast tanks are positioned at the front and back of the Suffren. When they fill with water, due to the opening of a hatch, the boat becomes heavier and sinks.
And when you want to go up, you send compressed air into the ballast tank, which will push out the water. Thus, you lighten the submarine, and it will go up.
Vous allez procéder à l'allègement du sous-marin et lui permettre de remonter.
If a submarine needs to change its angle up or downwards quickly, there are the hydroplanes, or vertical rudders.
The higher the speed of the submarine, the more effective the hydroplanes.
They're the little blades that are embedded in the front of the hull. They act like the canards or ducts on the Rafale fighter jet, which can apply the brakes in flight. But the main control elements are at the back, and their design is a revolution. They're X-shaped.
It's a world first. You can control each bar individually and do pretty much what you want.
The rudder is operated from the control room by a simple joystick. Yet powerful computers are needed to manage the 4 independent bars. And the result, with a submarine of 5,000 tons and 300 feet long, is quite different from the past.
We managed to build a ship that turns better than its predecessor, which was twice as small.
The boat's stunning performance is also due to the propeller. Design details are ultra secret. No image of this part of the vessel is available. The propeller is placed in a nozzle, here covered by a tarpaulin. The nozzle limits the noise the propeller generates, and this is fundamental as enemy ships have sonar so powerful that they can locate another submarine from miles away.
A submarine, or any boat, is betrayed by its noise. Submarines carry databases with the acoustic signatures of known boats. So, as soon as a new class of boat appears, it's most urgent for other navies to acquire the acoustic signature of that boat to be able to identify it.
Knowing that a hostile submarine is moving within a few miles of your own shores can be vital. To update their data, navies around the world use sound sensors spread across the oceans.
One of the techniques consists of dropping buoys, equipped with hydrophones. The seas are literally sprinkled with these devices, with the view that one of them will reveal the presence of a submarine.
The navies of the most powerful countries have databases listing the sounds and signatures of each submarine. But the Suffren's propulsion design makes it difficult to decipher and identify it.
With the Suffren, you can barely discern any noise at all.
So the Suffren not only defies detection by listening devices, it's also equipped with sound sensors never seen before. They're embedded all over the ship, in the bow, in the stern, on the sides. Small hydrophones that are triggered as soon as a noise is received.
When a sound hits this hydrophone, it will react with an electrical impulse. This in turn signals a given distance and a given amplitude.
However, these sound waves have a behavior that is not linear. Water temperature, salinity or density all have an impact on their curve.
You can have a wave that comes from the surface and will bounce off at some point underwater, re-reflect and bounce off again.
So, how do you broaden the sound wave spectrum and recover sounds that would pass under the hull? The engineers have come up with a surprising answer.
There's an additional antenna. It's basically a towed line made up of several hundred yards of acoustic sensors, which improve the ability of the submarine to detect what's going on around it.
This optical fiber, with a diameter of 2 inches, adds hundreds of ears to the submarine, so that nothing will escape it over a perimeter of several miles. Yet even if powerful computers analyze the sound curves, man is still indispensable when interpreting the results.
One of the key crew members on board each submarine is called Golden Ears.
Their job is crucial. They're able to recognize the nationality of a submarine and are trained to identify thousands of sound curves and translate them for the captain.
He can tell that there's a trawler above with a 2-stroke diesel engine, 2 propellers, and moving at a specific speed.
Its state-of-the-art equipment for detection, combined with near-silent running, makes the Suffren the perfect bodyguard, able to clear the path for a submarine carrying nuclear missiles. Yet it also allows it to be used as a base for clandestine missions by special forces, thanks to a removable structure, a first for a French submarine.
It's a container fixed on the submarine, which will carry the equipment for the frogmen.
This container, called a deck hanger, allows the special forces to get out of the submarine and reach land to carry out their mission. It's the most discreet way to bring men to the coast. However, developing the structure took decades, since its operation is most complex. As the men are starting their ascent from a depth of about 150 feet, the maneuver is extremely delicate for the balance of the sub.
They enter the hangar when it's still dry. You seal it off and then fill it with water. But you can't use water from the sea, as that would make the boat heavier. That's why there's a tank in the boat that doesn't serve any other purpose than to fill the hangar. Once that's done, you open the door and off you go.
The deck hanger is a tremendous advance for the new generation of submarines. Only 4 countries in the world have mastered the challenge of handling this structure. A totally removable caisson.
When you go on other missions, you take it off and have the clean lines which allow you to go fast.
Armed with a device for commando-style missions, equipped with the new cruise missiles or its wire-guided torpedoes, the Suffren is the nuclear attack submarine par excellence. It's a technological marvel. The combined effort of designers and engineers from hundreds of companies. A vessel that many states dream of having. This success is not least due to heritage. France has been building submarines for more than 100 years, and one of them has become a legend. The Ruby, a submarine launched in 1931. While the surface ships of the French Navy destroyed maybe 1 or 2 German vessels, the Ruby sank 22. It was a purpose-built mine layer, 216 feet long, designed to dive to 260 feet. On 22 patrols, it became the scourge of German inshore traffic.
The tonnage sunk by this boat is impressive.
Apart from laying mines, the Ruby could fire 5 torpedo tubes. Its record is unique in the French Navy.
Few ships have fought a war from beginning to end and proved their operational efficiency throughout.
In the 1930s, the Ruby represents the sum of naval technology. Yet it was a far cry from the capabilities of its successors, such as the Suffren, as the nuclear reactor did not yet exist. To reload the batteries that power the propeller and the entire boat, it was still necessary to surface, since the batteries were charged by diesel engines.
A diesel needs air to be able to run and to emit the combustion gases, so the submarine must surface regularly.
Le sous-marin doit faire surface pour pouvoir faire fonctionner ces diesels.
The Ruby's batteries had the advantage of being highly reliable with a very low risk of fire, a comforting asset for any submarine when running deep. But the batteries were bulky and their energy output limited.
That means you needed a large mass of batteries to obtain a significant autonomy.
The Ruby could only navigate 80 nautical miles underwater at a speed of 4 knots. As soon as the batteries ran out, it needed to surface to start the diesel engines that recharged the batteries.
A submarine on the surface is highly vulnerable and likely to be spotted and intercepted.
Lack of oxygen may be another factor that forces the commander to go up. Too much CO2 inside the boat requires an urgent ascent. To counter the risk of inhaling lethally polluted air, the Ruby could call on some infallible detectors.
To alert the crew if the atmosphere was nearing the critical mark, they kept a bunch of canaries on board, which would die before the air needed to be renewed.
To submariners back then, it was paramount to get as close as possible to the enemy without being detected. Yet underwater, they had to navigate blindly. There simply was no current device that could tell them their exact position precisely. The Ruby advanced by dead reckoning. The captain may calculate the speed of his boat, but any unforeseen current could take it far from its intended course.
You don't know exactly where you are. There's just a zone of probability.
To get your bearings, you had to surface and establish your position by celestial navigation, in other words, via the stars. Once the target lay ahead, the Ruby would approach it slowly underwater, using its periscope.
The periscopes were extraordinary optical gems.
Thanks to a set of mirrors, the periscope is a fantastic instrument to get closer without being seen. But there's a catch.
If the sea's calm and you're off a coast, you may be spotted just by extending your periscope.
Only the commander and his XO were trained to use it. When conditions were right, the Ruby could approach a port, its preferred target. Its mission, to mine the entrance and lay a deadly trap for any ship that passed above.
The Ruby carried up to 32 mines in 4 side containers, which held 8 mines each.
The mines are released by compressed air, one every 300 feet. As they weigh 800 kilograms each, the submarine must be quickly rebalanced to prevent it from rising to the surface. It's done by taking aboard water by opening a valve and filling the ballast tanks to compensate for the lost mass.
It's all a matter of calculation.
Mine laying is a dangerous business. A tiny slip, and it's the submarine that will sink in a few seconds. The maneuverability of the boat and the expertise of crew are crucial. Several other nations had commissioned mine layers like the Ruby, yet without similar success.
The boats of the German UC class almost all fell victim to their own mines.
Once a mine is released, it sinks to the seabed. There, up to 600 feet deep, it transforms.
Mines consist of 3 parts. One will rest on the seafloor. It's a ballast container that acts as an anchor and is connected by a cable or a chain to the actual charge, which floats below the surface like a buoy.
The release mechanism is blocked by salt. It starts to melt once in contact with water, and thus releases the explosive charge. The submariner's art consists of calculating the right length of the cable so that the explosive does not rise too far and becomes visible on the surface.
The contact mine is what you'll usually see in the movies, a sphere with horns or antennas. When you touch one of those, you trigger a chemical reaction, which will cause the explosion.
With 250 kilograms of explosives in the shell, the results are devastating. This is how the Ruby earned its outstanding reputation. Never before had there been a sub with a tally like that.
More than 22 ships sunk, almost as many damaged.
The Ruby was made a companion of the Order of Liberation, an honorary title shared with just one other French ship out of dozens that took part in the war. And when the old submarine was decommissioned in 1949, its fate was quite different from other ships.
One does not leave a companion of the liberation to the blowtorch of the scrap merchants. That's why, in 1958, it was decided to sink the Ruby in the Mediterranean, deliberately and respectfully. Since then, it has become an underwater attraction for divers.
The Ruby is one of those submarines that forged France's reputation in the naval world. 40 years on, it was the Redoutable and its nuclear reactor that provided France with the ultimate means of deterrence. Then, in 2020, followed the most sophisticated nuclear attack submarine in the history of the French Navy. The Suffren is the first of a class that will eventually include 6 vessels. Yet, there are already plans for the next generation of underwater nuclear missile carriers. From 2035 to 2050, 4 new vessels will leave the Cherbourg factories. The oceans cover 70% of the planet's surface. Many countries are trying to exploit the deep sea, eager for resources such as gas or manganese, copper and lithium deposits. Control and domination of the seas will continue to require a vast naval effort. Future generations of submarines will play a decisive part in whatever lies ahead.